purpose of this quick video is to explain how JUKE is capable of providing a persistent layer of network and storage for different schedulers. As distributed applications are becoming the new norm, organizations look at multi-cloud as a way to achieve that, and while doing so, they face issues such as isolated clusters and federations for each cloud provider. While schedulers such as Kubernetes, Docker Swarm, and others are great, they still don't provide a real multi-cloud layer, lacking persistency across networking and storage. Scaling up or down across clouds becomes time-consuming, and depending on a cloud provider's high availability has proven to be a risky bet. By creating a persistent network and storage control fabrics across clouds, JUKE helps organizations to solve these and other issues. With JUKE, the scaling of resources across clouds becomes invisible as it creates a normalization layer to different schedulers. Instead of implementing and managing different clouds, clusters, storage, networking, and other solutions, JUKE presents all resources as local to your scheduler of choice. And with a persistent layer of networking and storage, your containers have access to a unique distributed layer 2, as well as volumes that are distributed across multiple clouds. So you can create, move, and distribute containers, and they will carry their IPs and volume around based on predefined business rules. Let's use Docker Swarm as the example for this video. When we go into JUKE's compute layer, we can see that we have resources coming from local, AWS, and Google Cloud environments. If we dive deeper, we can see the instances across these environments. Let's click on View Instances for AWS. Here, you can get complete visibility into each node utilization, and with metrics across CPU, memory, networking, and others, administrators can quickly identify their overall infrastructure performance. One important item to notice is the instance's IP address. As mentioned, JUKE creates a software-defined networking layer, providing all nodes with a distributed layer 2. Same thing is presented when we look at the resources that are coming from Google Cloud. And as we focus on Docker Swarm for this video, if users wanted to deploy containers across AWS and Google, they would have to do a lot of different manual effort as well as manage 2 individual clouds. But let's have a look at the terminal and see how Docker Swarm is presented when JUKE is the underlying multi-cloud layer. When we come into the first node, we can run a quick Docker node list to get the status of our Swarm cluster. Now, notice that as part of our cluster, we have master or leader node installed in one of our AWS nodes, a worker node on another AWS node, and as a second worker on Google Cloud. This is made possible because of Docker Swarm sees JUKEs as the infrastructure layer instead of each individual cloud provider. If we run a Docker service PS web server, we can see a web server that is currently deployed across our distributed layer. If we scale it up or down, Swarm will utilize JUKE's data and control fabric and see it as a single cluster. Let's see with a quick scale up. We can quickly see that JUKE helps Swarm distribute the services across clouds seamlessly. The other point to explore is JUKE's distributed storage fabric that is persistent across clouds. Let's try and create a volume using JUKE's driver for Docker Swarm. Let's just now confirm it was created, and it's there. Let's now go to a secondary node that is part of our Swarm cluster. Let's use the one coming from Google Cloud. If we list the volumes, we'll immediately see the volume we created on an AWS node listed and available here. If we also create a new volume on top of JUKEFS, we'll be able to see it back on AWS. Again, it's a distributed multi-cloud layer. Now, if we just create a container, we can quickly assign our cross-cloud persistent volume to the container. Let's do it by creating an Ubuntu machine. We can quickly update the OS. Let's just install Vim so we can create a file as an example inside our persistent volume. Now, if we go to the data folder, we attach that as the volume, as a persistent volume. We can create a simple file and insert some content into it as an example. We can see the file was created. Now we can quickly go to our second node. And from there, we can start also a container and attach the same volume, the same persistent volume to that container. Let's just update the OS. Now, if we're going to the data folder, we can see the demo file we created before in the previous node. If we just run a simple cat command, we can see the content of the file. Overall, there are many other features that JUKE provides to not only Docker Swarm, but to other schedulers as well, such as Kubernetes and OpenShift. Features such as custom data tiering across clouds, persistent networking and storage, snapshots and clones, auto-scale up and down across clouds, moving containers, and more. There is also a free version of JUKE that is available for download. For more information, please contact our team and we'll be happy to assist. Thanks for watching.